In this video, we'll take a look at how to do some examples of ellipses. We're going to go on to the next page here. Now, even though it's not stated, I forgot to include these directions. For part B here, it says that the vertex of our ellipse is at 7, 0. The minor axis is 2 units long. But one thing that we also want to add in there is that the center is at the origin. Okay, so we know that's going to be at 0, 0. We're going to also find the coordinates of its foci. Let's go ahead and begin. So if the vertex is 7, 0, I'm going to go ahead and just draw my coordinate plane. I know that my vertex being 7, 0 will place us this right here. And then we'll also have another one on the other side. So negative 7, 0. Okay. And also because that's my vertex, I know it's going to be a horizontal ellipse. The minor axis is 2 units long, meaning that the entire length from end to end is 2 units long for the minor axis, which means since the center is at 0, 0, that must mean I only go up 1 and down 1 as well. That's going to give us a length of 2. From there, I can go ahead and draw my ellipse. There we go. And with enough practice, your ellipses should look somewhat symmetrical. Okay, and now we're going to go ahead and find the equation of our ellipse. Keep in mind, because it is a horizontal ellipse, horizontal ellipses always look like x squared plus y squared with some values attached to the bottom. Okay, so we're going to make sure we have x squared, we have y squared, and of course we always have a 1, right? It's always equal to 1. Now, based on our a and b values, remember that the a represents the major axis, and in this case, the length is actually going to be a length of 7. So this will be the same as 7 squared. And then the y squared is going to be for the minor axis. That's going to be this length here from the center, which is the length of 1. So that's going to be 1 squared. So our equation is simply x squared over 49 plus y squared over 1 equals 1. There's our equation. We also need to find the coordinates of the foci. So keep in mind that the foci can be found by doing c squared equals a squared minus b squared. So c squared is equal to 49 minus 1, or that's going to be the same as 48. And if we square root both sides, remember that the c value being a length cannot be a negative, so we should only have the positive square root of 48. And if we think about what 48 is made up of, that's what, 12 and 4, and that's 4 and 3, so we have a group of 2 there. So c is going to be 4 square root of 3. So remember, this is not the foci. The foci are actually at the coordinates of xy, and the c value being a length of 4 root 3. 4 root 3 is about, I'd say about 6.9 or so. So, here's 7, 0. So our foci is actually going to be really here, right around that area. That's why it's the ellipse is so slender, because the foci has been stretched out so much that you now have a really slender ellipse. So the foci would be using the ordered pair 4 square root 3 comma 0. Notice how we are very specific in our ordered pairs. It's not just a decimal value that's rounded. And our other foci is going to be at, or rather our other focus is going to be at negative 4 root 3 comma 0, because it goes on the other side as well. Okay. All right, number 3. Sketch the graphs of 4x squared plus y squared equals 64 and x plus y equals 4 on the same set of axes. Then solve the system. Let's go ahead and do that. So when it comes to the equation, let's put our ellipse in green. Actually, we're going to color code our ellipse versus our line. So let's go ahead and graph our ellipse first. So I noticed that because I don't want 64 actually. I want to divide by 64. So that way I can actually get my ellipse to have a value of 1 on the other side. So that'll give us x squared over 16 plus y squared over 64 equals 1. So there's the equation of our ellipse. What does that tell us? Well, the x axis is going to have a length of 4, and then the y axis, the vertical length is going to be a length of 8, since these are going to be, the values are squared, basically. Let's go ahead and graph that. So I do notice that my y value 8 is a lot longer than 4, so I'm going to make sure my y-axis is drawn accordingly. My y is a lot more vertical. It's going to go up to 8, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we have also the x values going to 4 and negative 4. Well, since I actually drew it directly at 8 and 4 and all those values, I'm going to go ahead and just construct my ellipse. Just like that. Oops, I did say I was going to color code this, didn't I? Let me redo that. Okay, so there's our ellipse. And then now let's do our line. Our line being x plus y equals 4, that means it has an x-intercept at 4, and it also has a y-intercept at 4. 1, 2, 3, 4. Okay, from there we can just go ahead and construct our line. There we go. Oops, that was off. Let me redo that. There we go. Okay. So we see that the line intersects the ellipse at 2 spots. Well, where exactly is that going to occur? We got to find that out. So let's go ahead and solve a system of equations. Now, when we solve a system of equations, remember, you can either do elimination or substitution. And I think for our purposes here, it definitely looks like substitution would be the better route to go. So let's go ahead and plug in that negative x plus 4 in for the y value. Okay. So we're going to get 4x squared plus, and then our y value was negative x plus 4, and then that's going to be squared, equals 64. So we get 4x squared plus, and then we get x squared minus 8x plus 16 equals 64. Simplifying, we get 5x squared there, minus 8x, and then subtract the 64, we'll get negative 48, so minus 48 equals 0. All right, is this factorable? Let's see here. We can do a 5x and x, and a 12 and a 4, I believe. You can double check my factoring there. Let's see if that works. That's going to be a minus 4 and a plus 12, I think. That should work. 5x squared. Yeah, that works. Okay, so from here, we see that x is equal to negative 12 over 5, and also x is equal to 4. Okay, so if we have the x values, well, we do notice that the 4, bingo, that's right on the money right there, right? And then we also need to find out what this one is at. We see that that is an x value of negative 12 over 5, but where is the y value? So we got to find that, right? So let's just go ahead and plug in the x value into x plus y equals 4. That will be the easiest, I believe. So negative 12 over 5 plus y is equal to 4. Oops, add 12 over 5. So we should get 32 over 5 then. So this x value will have a y value of 32 over 5. Okay, and then so there it is, 32 over 5. There is one of the intersection points. And the other intersection point, I know it looks kind of obvious on the graph, but let's just make sure, right? X plus y equals 4. Again, we'll plug it into this equation here. So 4 is x plus y equals 4. Oh, that must mean that y is 0. So our other ordered pair is 4, comma 0. Remember, show your work. Show all your work. Just because you see it on the graph, you want to double check, verify algebraically. So those are your two ordered pairs that are where the ellipse and the line intersect. Those are your solutions. All right, let's do one more. Number 4. Find the coordinates and vertices of its vertices and foci of the ellipse. How do we know it's an ellipse? Because we see x squared plus y squared. So that's how we know it's an ellipse. Okay. So if this is an ellipse, we remember we want this in the form of some kind of x squared plus y squared over something, right? Equals 1. Well, if you want it equal to 1, that must mean that first of all, you want your number on the other side. So let's kick that 84 over. And I'm actually going to regroup things so that we have x's together and we have y's together. Equals negative 84. Okay, now, one other thing I'm realizing here is hopefully what you're seeing is that the process that we need to do here is by completing the square. Unfortunately, remember from a previous chapter, when we complete the square, we have to have the a value of your trinomial be a value of 1. Unfortunately, this 25 is not a value of 1. So I'm going to just rewrite this a little bit more. And what I'm going to do is I'm actually going to factor out the 25 from both the y squared and the 100y. So now I'll have minus 4y. So now I actually have the 25 sitting outside of my what will be a perfect square trinomial. From here, we can now go ahead and apply completing the square, right? So what we're going to do is we're going to take our negative 6 divided by 2 and square it, okay? And then remember, you also do the same thing on the other side. We add on a negative 6 divided by 2 and square it. And then we're going to have to take a look at the negative 4, right? We're going to have to take negative 4 divided by 2 and square it. And then on the other side, we also add the negative 4 divided by 2 and square it. But be very careful here. Remember, on the left side, you technically don't just have negative 4 over 2 squared. You also have a 25 being multiplied by that value as well. So we need to multiply this by 25 as well. Okay, so be very careful with completing the square with a values that are not 1. Okay. Now let's go ahead and simplify this process through. We see that this perfect square trinomial will now become x minus 3 quantity squared. I just take my x value there, and negative 6 over 2 gives me the minus 3. Okay. Plus 25 times, what do we have here? We have y, negative 4 over 2 is minus 2 squared, just like that. And that kind of gives us our perfect square trinomial. The entire left side is nice and simplified now. And now let's go ahead and add up what's going on the right side. So let's go ahead and see what do we got. Negative 84 plus negative 6 over 2, so negative 3 squared. So that's like adding 9 to it. And then here we have negative 2 squared is 4. So that's really like adding 100 to it. Okay, so if we do that, 100 minus 84 plus 9, we get 25. Okay, so there we go. We have our almost ellipse equation. Now all we need to remember is on the right-hand side, we need to make that equal to 1. So divide both sides by 25. Divide everything by 25. Okay, and in doing that, you now have your ellipse equation. X minus 3 squared over 25 plus y minus 2 squared over 1 equals 1. Now the reason why I still write over 1 is because that's going to help me in determining what that ellipse is going to look like, right? Because what we need to do is actually sketch the ellipse. All right, so looks like I'm running out of space here, so pardon me. I'm actually going to, I hope you have room still, but instead of just kind of squeezing it all down there, I'm actually going to bring my work over here, and I hope that you just leave your own space so that you can do number 4a on your own. Okay. All right, so let's go ahead and graph this. So I'm going to draw my coordinate plane. Okay, well, this problem is a little bit different now. What we see is actually that the center point has been shifted. How does it shift? Remember, if you see a number contained within parentheses, you're actually going the opposite direction. So x minus 3 tells us we're going to shift 3 to the right. So 1, 2, 3. You know what? I'm just going to add a little bit more numbers here, just so I can properly graph this. Okay, let's go ahead and graph it now. So my center says that I should go 3 to the right, and y minus 2 tells us we should go 2 up. Remember, you're doing the opposite of what that sign is if it's contained within parentheses. So we want to, our center is basically going to be at 3, 2. So go to 3, 1, 2, 3, 2. There is our center. Okay. And then So now we need to find the vertices. Now, if the x value has the 25 directly below it, remember that number is larger, right? So therefore, this is going to be the major axis. And therefore, if the major axis is connected with the x value, that's telling you you have a longer ellipse, which means it's going to be a horizontal ellipse. Which means with that value of 25, which means that the a value is 5, we can now go from 3, 2, go over 1, 2, 3, 4, 5, and that's going to be our center location. Okay, where are we? Let's double check. The vertices are at, let's see, if I was at 3, 2, 4, 5, 6, 7, 8. So my vertices will be at 8, 2. Okay, and where's my other vertex? Well, I need to go to the left now by a unit of 5. So 1, 2, 3, 4, 5. So right there, that's going to be my other vertex, which is at negative 2, 2. Okay, so there's my vertices. Check. Now we got to find the foci. Before we find the foci, let's actually just finish sketching the graph. We know that the 1 being the b value, the b squared is equal to 1, so b is still 1, is connected to the y value, so that just means you're going up 1 and down 1. These are your co-vertices. Your co-vertices are at 3, 2 is the center, so now we're going to be at 3, 3. Our y unit moves up 1, and then it also goes down 1, so 3, 1 is going to be the other co-vertex. From there, I can go ahead and sketch my ellipse. Ooh, that is an ugly ellipse. All right. Okay, so now we're going to draw and find the foci. Remember that the foci can be found by doing c squared equals a squared minus b squared. And so our a squared is 25, minus b squared is 1, so c squared equals 24. Or if we simplify that, what's that? 12 and 2. 2 and 6, 2 and 3. Oh, so we can only take out one group of 2 there. So we'll have 2 square root of 6 basically. Okay, so c is equal to 2 square root of 6, plus and minus, but remember, you can't have a negative distance, so it's only a distance of 2 root 6. Well, how do we graph that? Well, if your center is at 3, 2, then your foci go from the point 3, 2, and it moves to the right by a unit of 2 root 6. And it moves to the left by a unit of 2 root 6 as well. Okay, so in order to write that properly, the foci can be found by saying, if you start at the center, and what you're doing is moving right and left, you're adding that to the x values. So you're saying 3 minus 2 root 6, and the y value doesn't change, so it's still going to be along the y value of 2. And then the other focus is going to be at 3 plus 2 root 6, comma 2, just like that. Okay, so you have now found all the appropriate parts of the ellipse. You box that. Okay, so you have the vertex, you have the co-vertex, you have the foci, and you have the center. I know it didn't ask for the center, but you know, you'll definitely need to have that information anyway, so you might as well just box that. Okay. All right, so that's pretty much going to conclude our lesson on ellipses.